Good morning. I'm going to go ahead and walk you through how I would kind of set up for the Chapter 3 assignment. And so the first thing I would do is go to the Chapter 3 assignment link and open that up. And on my screen, I can go ahead and stretch this out so I can read the whole assignment. And so basically, I want to download this template so that I can use it to prepare for this assignment. So I'm going to download it to my folder for this summer, and I'm going to rename it as the assignment asks us to say Bets Chapter 3, and I'm going to put a 1 on mine because it is actually the second time I've walked through this exercise. Okay, so now I've got a blank template, and I'm going to show you how I would work with that in just one moment. So here is what it opens up to, right? And you can see it's that Bets Chapter 3-1, and I'm going to enable the editing, and I'm going to go to the data tab, and I'm going to see that's the data that comes from pages 93 and 94 of the textbook. So now that I have it downloaded, I'm going to kind of follow along with, there is a Chapter 3 assignment help that's been posted, kind of the steps that I would take. So I've downloaded it and I've saved it. I want to go to pages 93 and 94 of the textbook. I think it would be helpful if you'd read the analytics assignment. And then we're going to start working with the data. And the first thing that we're going to do then is we're going to add a tab. So I add a tab, and I'm going to rename that. And we're going to rename it Simple. And I'm going to set the data up so that I can use the data that is in this spreadsheet to do the evaluation. And so I kind of need for all of this data to be in one long set of rows. So I've got week 5, 4, 3, 2, 1, which are before the current time period, and then I have the data from the current time period moving forward. And I want this average. I'm going to go ahead and format the cells to be number and to show us 1 decimal point there. Okay, so here's my data, and here's the current time period. So I'm going to go ahead and highlight that in green, right? And so we can see that from 1 through the next 13 time periods, and then the previous 5 time periods before that. So on this Simple tab, I'm going to try to answer the question for the first question in this analytics exercise. And it says, consider using a simple moving average model. Experiment with models using a 5-week and a 3 weeks past data. The past data in each region are given below, and so we've got that in our spreadsheet. We're going to evaluate the forecast that would have been made over the 13 weeks using the overall mean absolute deviation, mean absolute percent error, and tracking signal. So what that means is at the end of the day, I need to be able to calculate the mean absolute deviation, the mean absolute percent error, and the tracking signal. But the first thing that I need to do is start off by calculating, let's do the 5 weeks simple moving average. Okay, and so if I'm going to do the 5 weeks simple moving average, I need to go ahead and set it up so that I have the labels, and so then here's the time periods that I'm going to be using are 1 through 13, right? And so to set up my simple moving average for 5 weeks, I'm going to use function, average, and I'm going to use the previous 5 weeks. So I'm doing Atlanta, so I'm doing B2 through F2, okay? And I see that that comes out to 41.6, and I can just drag that formula down, and then that should do the same thing. If I hit F2, it's going to show me that I've got the previous 5 weeks, right? And I'll do one in the middle and check the same thing. Okay, so this is my 5-week forecast. Excuse me. This is my forecast for week 1 based on the 5 previous weeks. Okay, and I can do that same thing by just copying it over, those formulas over to the next 13 weeks. And what you'll see is that because those are relative, now the formula, the forecast for week 2 goes from the previous week 1, -1, -2, -3, -4. And you can see that it just continues to move over for each 5-week range. Okay, so, and then I'm going to go ahead and set this up to be I want my numbers, so I'm going to go Format Cells, I'm going to do Number, and I want it to go ahead and show me just in 1 decimal point. So I'm going to go ahead and click on 1 there. All right. So now I've done the first part. I've got the actual 5-week forecast. The next step is to actually calculate the forecast error. Okay. And so to do the forecast error, I'm going to need to do that for all 13 weeks. So I'm going to copy my 13 weeks here, and off to the right here I'm going to type in forecast error so I can just keep track of what I'm doing. I'm going to organize that so that that is right justified, right, so I can read it. And I also need then each of the distribution centers and the total so I can get the actual forecast error. Now, forecast error is the actual demand. So for week 1 Atlanta, that was 33 minus what we forecasted. For week 1 Atlanta, that was 41.6, right? And I could do that individually. I could go for Boston. It's going to be the actual of 26 minus the forecast of 40.6. So it's always, forecast error is always actual minus forecast. Or, because again these are relative cell references, I can just copy and drag that formula down. Okay, and then I can also then highlight those formulas and copy them across for the next 13 weeks. Okay, and then if I'm going to calculate mean absolute deviation, the formula for mean absolute deviation is the average of the absolute values of forecast error. Okay, so I need then to calculate the absolute value of forecast error. Okay, so I'm going to again right justify that and then copy down the distribution centers and copy across the weeks that I'm looking at. Okay, and so then I'm just going to take equals the absolute value, ABS, of the error for Atlanta for week 1, right? And again, that just is going to remove any of the negative signs and make everything a positive value. And I can copy that down and across, so now I have all 13 weeks absolute value. Okay, so if you recall, question 1 asks us to evaluate each forecast based on mean absolute deviation, mean absolute percent error, and the tracking signal. Okay, so if I'm going to calculate mean absolute deviation, now I'll bold this and center it. I just need to take the average of all 13 weeks absolute value of the forecast error. Okay, and again, I just want that to show 2 decimal places, so I'm going to format cells, number, 2 decimal places. Okay, and I'm going to drag that down, and that's going to give me my mean absolute deviation, which is the average value of the absolute value of the forecast error. So mean absolute deviation tells us basically what the average amount that the forecast is either above or below the line, okay, which is our forecasted line. So on average, we're 11.17 units off of our forecast for Atlanta. And if I looked at Chicago, we're 18.45 units off of our forecast. Okay. Then I need to calculate mean absolute percent error. And so I'm going to just give that a heading, mean absolute percent error. And I'm going to bold it and center it. Okay. And mean absolute percent error is our mean absolute deviation divided by the average demand. So I've got the mean absolute deviation, and up here we've calculated our average demand. Okay, and I want that to show 3 decimal places, so I'm going to change this to 3 decimal places, and I'm going to copy that down. And so it's basically telling us that our forecast is off on average, the mean absolute percent error, we're off by 28.1%, 25.6%, 39.1%, etc. Okay, so we can see we've got some challenges with our forecast there. Okay, our tracking signal is another way that we can evaluate our forecast. So I'm going to center it and bold it. So a tracking signal is basically a measurement that tells us whether the forecast average is keeping pace with any genuine upward or downward changes in demand. So what we're going to do is we're going to take our tracking signal formula, takes our running sum of forecast errors, and divides it by the mean absolute deviation. Okay. We don't currently have the running sum of forecast errors on our tab, so let's go ahead and calculate that. I'm going to put a label for it and bold and center it. So here's our forecast errors, and the running sum of forecast errors basically is just the total of all of those errors. And so what that's telling you is at the end, so let's say over this 13-week period, we've actually missed the forecast by negative 3.16 units. Okay. However, if we look at MAD, on average, we were 11 units above or 11 units below our forecast, okay? But in total, the pluses and minuses even out to show that we have a negative 3.16, okay? And so I can do that, my running sum of forecast errors, I can total those up across each of these time periods. So I'm going to back into this again and walk you through it. So let's look at this time period for time period 1 for the Atlanta distribution center. In time period 1, our forecast was 41.6 and our actual demand was 33. So negative 8.6 indicates that our forecast overstated, or our actual demand was under our forecast by 8.6 units. Okay, so our running sum of forecast errors says at the end of 13 weeks, we've missed our forecast in total by a negative 3.6 units. Okay, and to get our tracking signal, this formula for our tracking signal is the running sum of forecast errors divided by our mean absolute deviation, right? And so I can then, again, copy that down. Now, in this course, I want you to understand how to calculate the tracking signal, and just understand that that, again, tells us that whether the forecast is keeping pace with any genuine upward or downward changes in demand. All right, so I'm going to go ahead and go Format Cells, Number, and let's go ahead on the tracking signal. Let's use 3 decimal points on that as well. Okay. All right, so that's how you do for the 5-week forecast. Now, if I were you, I would consider just doing this to do my 3-week forecast. Copy, paste, right? Change this to 3 weeks. And come into this forecast, right? Clear contents. And create then your 3-week forecast by going function, average, and we want the previous 3 weeks rather than the previous 5 weeks. Okay? So I'm going to click OK. I can drag that down. I can drag those across. And I now have all of the information that I need, except for we need to look and make sure that the division works. Okay? So we have, for our MAD, right, we've got the average of each of those, so that works. For our MAPE, right, we're taking the MAD divided by the average demand. And for our tracking signal, we're taking the MAD divided by our our running sum of forecast errors. So that's how I would work through to get my data to evaluate for the simple. Okay, so that's all I'm going to do in this YouTube video. I'm then going to stop this one and start another one where we talk about the exponential smoothing. All right, so that'll be the end of this recording.